Well, hi everybody. How are you today? I hope you're all doing well. So this video was going to start out as kind of a continuation of the phase linear 400, and I figured pretty much it'd follow a similar pattern. And well, as it turns out, this is going to be an audiophile classic. This one has to be one of the best ones that I've seen so far. I was really impressed. I took the cover off, is all I've done so far. Haven't plugged it in, haven't tested it. I was going to kind of get things ready to line up the camera so we can look inside, kind of as a continuation video. And when I took the cover off, I was absolutely flabbergasted. This is beautiful. I love it. All right, can't really see much right now, can you? A little bit of writing on the capacitor, but other than that. But upon further inspection, closer inspection, we'll get to the most fun here in a minute. But you can see there's a couple of diodes, and they're just tacked on there. There's no mechanical connection. They just blob soldered it on there. There's this blue wire that's, again, blob soldered onto the bus bar there for the ground. There's some solder. There it is. Used to tie these two wires down. Move over a little better. There are some resistors just kind of daisy chained together. These are normally would be our 47 or our 75 or 7.5K resistors. And if you look closely, they're just kind of flapping in the breeze there. There's a little tiny quarter watt in series with two 4.7Ks. This is a little newer amp, a series 2, and it has the it does have the LM351s, and they're the the dip package rather than the metal can. But the piece de resistance, excuse my poor French, I never could speak French, is this. I open it up and there's a bag of parts, what it looks to be, but these wires are going into the bag. So let's pull this bag out together and see what this is. Let's back the camera up here a little bit. It's a piece of foam in a plastic bag and a relay. Wow. It's a homemade something. Kind of neat work they did. But look at these skinny, thin little wires. So there's a double, what is that? A double pole relay, really small one, very delicate, tiny little contacts on it. These appear to be push terminals, and they are. Look at that. So you can disconnect it. Quality. And there's a plus and a minus, and that goes over right to here. So the red wire, so these diodes are in reverse bias. So you can see the cathodes are pointing towards the positive lead. And so these must be Zener diodes. So apparently they have a Zener diode, two Zener diodes in series coming off of the B+, which is 100 volts on these. And it goes into this thing that goes through, zigzags through a bunch of resistors. Teeny tiny little resistors. Look at those things. Look at those baby little resistors. And then there's two more diodes, a capacitor. And what's the coil on this relay supposed to be? There's no markings on it. So your guess is, this looks like Judging by the amount of turns of wire on that thing, I would say pretty high voltage coil. What's this say? If you can read that. I don't know what any of that means. That's just a part number. It appears that they're using this capacitor and these resistors with this as an RC time constant to turn this on. And then the two sets of contacts go somehow in line with your speaker terminals, and then they cut the speaker terminal. Look down here. It appears as though they've cut the speaker terminals off. Look at that. So here's your speaker wire for this channel, and it goes to the Zabel network, which it has a burned up resistor or something on it, and then this sand resistor, or this ceramic resistor, and then your cap, and then this tiny little pink wire, and then the other end of the tiny little pink wire goes to speaker terminal. So all of your 350, 360 watt power goes through this little pink wire. Audiophile approved, man. Totally awesome. What do you think? I like it. And then here's the green wire for the other channel, doing the same thing. Got all kind of hair. Little wire hairs hanging off. Yeah. Quality. Nothing but the best. I love it. And I like the case. The insulated case. That's just beautiful. Well, let's put it back together and see if it works. Okay, let's take the plug. We'll plug it in. The other thing I noticed was this one's saying that it's 220 to 240 volts AC, but looking down on the side here, the terminal strip, there's a terminal strip down here with all the wires for the primary of the transformer. That appears to be wired for 200 or for 120 volts. Which would make sense because there's a 120 volt power cord on here. But I'm not so sure that this power cord is original to the amp, but it might be. I don't know. It's all a mystery. All right, so I have this plugged in. Let me turn on the transformer here, the isolation transformer. And okay, let's turn this on and see what happens. No, Tony, no, I can't take it. The sound stage is closing. I feel it closing in. It hurts. It hurts. Don't do it. I'm doing it. No, I'm doing it. I'm doing it. No, I can't look. Well, that was rather uneventful. It looks like our speaker thumping relay thingy is not pulling in. Nope. Huh. Well, let's use this meter because it's green. I like green meters. I don't know why. It's just cool. So let's use it. It's better because it's green. It's not yellow. Well, there's voltage there, but it's not 100 volts, and that's because I have a 110 watt current limiting bulb on there. And that's probably why this isn't pulling in. But strangely enough, the bulb has not stayed. I mean, it went dim. So obviously there's no shorts in there. I see a soldering iron, oops, right there. It melted right through the wire. So we'll have to kind of proceed with caution. But, well, the good news is there's no dead shorts. At least I didn't check any fuses, though. So that's a speaker anti-thumping circuit, I'm assuming. I don't know. So now that we've properly chastised the audiophile here, I really want to see if I can make this thing work as it is. And then, of course, I'm going to rebuild this thing. But, yeah, I just want to see how it works the way it is. I don't know if anything else has been done to this, but obviously somebody was a little bit, enterprising to do this. I don't know. So let's go with a bigger bulb. I'll turn this back on. I'll go to the 300 watt bulb and let's turn this on again. I mean, the LED boards are kind of wackadoodle looking. I don't know if you can see that. Let me turn some lights off here. Maybe you can see. I have there's a couple lights here and a couple here on both sides. That might again be because of lack of enough power. Let's check our voltage again. It's still only 50 volts, and that's weird because I went from a 100 watt bulb to a 300 watt bulb, and it really didn't increase the voltage at all. So maybe this thing is wired for 240 volts. It might still be. It appeared like the two primary coils were in parallel, but maybe I'll have to take this apart a little further. Maybe this really is wired for 240. But has a 120 volt cord on it. That's bizarre. Really weird. I'm going to have to look at this a little more carefully. Okay, I don't know how visible this is going to be because it's hard even for me to see it here in real life. But if you look down in here, it is indeed wired for 240 volts. So this... Let me see if I can find a little pointer to help you out. So this top blue and yellow wire is on one terminal. This brown wire at first looked like it was wired in parallel with this, but it's not. It's on the next terminal down. And then these two wires here, this brown and yellow and this blue, are wired together. And looks like the incoming line, the white and the black wire, are going onto this and this. So it is absolutely wired for 240 volts. So basically they have 240 volts transformer connected to a 120 volt power cord. And this is obviously electric cord. You see that? Look, electric cord. So that is definitely not factory. All right. Yeah. This is an audiophile special. Absolutely. I think the sound stage is going to be the width of the Grand Canyon with this. We have to make it work. So I have two choices. I can rewire this, or I can find my boost transformer and boost it up to 240 and see if this thing comes on. Okay, so I have this big old transformer that I ripped out of an old x-ray machine a long time ago. It's been sitting on the floor. And I wired it how I think it needs to be. And I stuck this janky plug on here. What could possibly go wrong? I mean, heck, look, it's got a whole bunch of fuses on it. How bad could it be? So Yeah, we got 220 volts roughly. Let's turn the transformer on. There we go. And let's see if we have voltage on the transformer. Let's see, can you see this? I don't know. Watch Tony electrocute himself. 220 volts, look at that. Isn't that nice? All right. So let's go over to DC volts and let's move over to the amplifier. And I have the scope connected to it and I turned it on. As a matter of fact, let me change the scale because I don't know. I just want to see if there's any offsets. I'm going to go down to like 1 volt per division and see if there's any kind of, well, there's already negative voltage on there. I don't even have the thing turned on. I don't know if that's my scope wigging out. I don't know. So let's see here. Do we have everything in shot here? Yeah, I think so. Okay. Let's turn this on. Well, that's good. The light flashed on and off. That little relay came in. It works. Okay. I mean, that doesn't mean anything. It just means there's enough volts on here. Let's see if I can electrocute myself on this. So there's 88.989 volts across there. And, well, let's see what's on the scope. Yeah. I'm at 50 volts per division, and I've got, looks like a dead short on one channel. See that? I got a bunch of oscillation on, well, I have some oscillation on this channel. See what it looks like. That's just a tiny little bit of noise. I think that's partially my scope doing that. But yeah, we have a bad channel. Huh. But that stupid little relay came in. How about that? Look at that. Can you see it? Here, let me turn the thing off and see what happens. See how long it takes to shut off, because this thing has to bleed down. There it goes. Huh. And then our voltage is coming down up here. That's the other channel there. But that's because of imbalance of the transistors. Let's turn it back on again. There. And then I'll go down here real quick. That pulled in. So that is a delay circuit. As janky as it is, it works. But, yeah, these these transistors right here are already getting really, really, really too hot. Turn it off before we fry everything. Okay, well, I think we have a shorted channel. And the thing's wired wrong, and it has the wrong plug on it, and it has this mess, and everything that could be wrong is wrong. But I have a transformer with a bunch of fuses on it. Okay, so doing a quick assessment of all this, this thing's kind of a mess. I mean, I bet you could probably replace some bad transistors and the thing will work. But, you know, I'm not going to do that. I do stand corrected. I talked about that there is a company that makes aftermarket boards for these. And apparently, after I posted that up and talked to Dave, you know, my buddy Dave, he enlightened me a little bit about them. I said that it was Oak Island. I was wrong. Oak Island is an island out in Canada someplace, and there's supposed to be some buried treasure there, and there's this television show where a whole bunch of people have been digging a bunch of holes there for how many seasons, and they never find any treasure. That's what that is. The boards are made by a company called White Oak Audio. Not Oak Island, but White Oak Audio. And I don't know anything about them. I did a quick Google search and I got some pictures of some boards that they put on here, and there's a couple people that made videos that they put the new boards in. They're all redesigned. I think it looked to me, and again, I don't know anything, but just from the looks of it, it looks like it just completely, totally redesigns this thing into another amp, which might be a good thing. I don't know. But I decided, Dave discussed whether I wanted to go that route or we should do that, and I've just decided no. I'm going to do something similar to what I did to the 400, maybe a little more refined on this one, and we're going to kind of rebuild it. I'm going to try to do a little better job with the schematics for all of you next time. I'm going to actually take a JPEG of the schematic and post it up in the video, so you can do a screen print of it and then print it out on your printer and then follow along with me as we go through it. Some of you have problems with lighting and focusing and things on your screens when it gets through YouTube. When I watched that video on YouTube on my end, on my computer, it looked pretty good, but that doesn't mean anything. Everybody has different monitors, different computers, whatever. So I'll try to make it easier to see. All that said, all kidding aside, I probably should say this. If you don't really know what you're doing with voltage and power supplies and things, this is not a good idea. I did this kind of as a joke a little bit, but also because I wanted to power this up without actually disrupting anything from how it originally was. Normally you would not do something like this, but yeah. So I'm going to go through, I think, in the next video, and maybe, I don't know. Why don't you all give me some suggestions where I should go with this video? I know what I want to do. I'm going to restore it similar to the phase linear 400 that we did in the last video. But would you like me to do this as a solder and chat? Would you like me to do this as really highly technical, where I go through schematics and bore you all with a lot of talk and schematic looking things? Do you want me to just go through and do the work and then come back to show you and explain what I did, and then we'll do testing, how we look at all the different distortion and all that stuff? Let me know, because for me to run the camera, wherever I turn the camera on, it doesn't matter to me in post up there. It's whatever you guys like. So what I can tell you is it's probably going to be a longer video. It's easier for me to just do one video than it is to make multiple edits and multiple videos and multiple uploads. I don't have the time with my job and everything. So those of you who don't like that, it's real simple. I do this all the time too. For videos that are too long for me to watch in one sitting, I kind of take note at where I stop, because there's a progress bar on YouTube for the videos. I stop at that point. I come back at another time and I just move the little slider over in the video to the time mark that I stopped at. And sometimes YouTube even remembers where you left off on a video. If you just go back into it, it'll pick up where you left off. It does that sometimes for me, sometimes not. But it's not hard to do. And I don't understand people get really uptight about the length of a video. It's a real easy fix to do that. So, you can whine and cry about it, or you can get with the program and use the technology that we have, right? That's why YouTube is so versatile, to be able to do that. So that's what I'm going to do. I'll probably do a longer video, but I'm going to do it, and I'm going to kind of pay attention to the comments, what you suggest, and see what we can turn this one into. I can tell you cosmetically, this amp is in fantastic condition. It's beautiful. So I really do want to make this thing nice. I don't want to turn it into a whole new amp. I want it to retain its original character. Although I will change some components, maybe get rid of some components that are getting old or unreliable or something, replace them with newer ones that might be more reliable. I'll do some things like that. Obviously, we'll maybe replace the capacitors, put a little bit better rectifiers, little mods that'll make the amp, again, just like the 400, make it more reliable and safer on your speakers. Of course, we're going to have to remove this. I get what they were doing. I think this was an attempt to get rid of the speaker thump, because all this is, the coil is directly connected to the capacitor here, to the power supply. So really, if you had DC offset or anything, it's not going to, well, this does. One channel has severe DC offset. It still pulled the relay in. This thing would still have fried the speakers. By the way, if you notice that, let's turn this on again for just a second. Okay, I'm going to turn this on. And I'm going to go back up here, and then I'm going to end this video here, but I'm at 50 volts per division. Here's 0 volts. There's 50. There's almost 90 volts there on that blue line. So that channel, which happens to be the left channel or the right channel has 90 volts DC right on the speaker terminal. My scope is connected right on the speaker terminal. See it? That blue probe, it's right on the speaker terminal. There is 90 volts there. If I were to connect my speakers right now, well, I'll show you. Let's look. Okay, you see it? So if I go from here, and this is going to get hot, so I don't want to burn anything up, here to there, 88.7 volts on the speaker terminal right now. That would go directly into your speaker. That's why they call these flame linear. All right? Nothing will protect you from that, because there's no speaker protect circuit. That's where the name flame linear came from. Okay? So it's not people that are cutting down on an amp that are on Bob Carver or making fun of him or anything like that. These amps had that one flaw in them. Remember, this is early technology. This came out in 1970. It was developed in 1969. There was nothing like it. I mean, it is cutting edge at that time. So, you know, to get something this powerful in this small of a package was unheard of at the time. But there was a few things that we had to learn along the way from it. And that's one of them. So that's it. So let me know in the comments how you want me to do the video. And until next time, I wish you all peace, joy, happiness, and good health in your lives. I hope all is well with all of you. I wish you all the best. And we'll see you again real soon. We'll be working on this. Take care, everybody. Bye-bye.